Open up your math journal and we are going to take notes on simplifying radicals. So you have this paper of notes. First thing we do before we're going to do this is we are going to write perfect squares. So perfect squares. Perfect squares are whenever you take any whole number and square it, and the result is your perfect square. So we'll list them out. So 1 squared is 1. We're going to list them all the way out to 20. 2 squared is 4. 3 squared, 9. 4 squared is 16. 5 squared, 25. 6 squared, 36. 7 squared, 49. Squared, 64. 9 squared, 81. 10 squared, 100. 11 squared, 121. 12 squared, 144. 13 squared, 169. 14 squared, 196. 15 squared, 225. 16 squared, 256. 17 squared, 289. 18 squared, 324. 19 squared, 361. And 20 squared, 400. These perfect squares are going to help us simplify radicals. So a radical is like a square root, but there are different kinds of roots. You could say a cube root, a fourth root, a fifth root. You can have any number as your root. So right here is where your root is of your radical. It's right inside this little, it almost looks like a check mark. So this is called your root. The number inside of the square root, or the root right here, is called the radicand. Radicand. Which all of it together is called a radical. If the root is not written, it is automatically a 2. And so a root is asking basically what times itself gets that number. So if it was a cube root, it'd be like what times itself 3 times gets that number. We're going to just be dealing with square roots though. We have 2 different ways to simplify radicals. One way is using prime factorization. So let's think on what prime factors are, or prime numbers. Prime numbers are numbers that are only divisible by 1 in itself. So 2 is the first one. 3, 5, 7, 11, and 13. And it goes on. The second way is going to be use perfect squares. So we'll look for perfect square factors of the numbers that are inside the radical that we can simplify. I'm going to teach you the perfect square way, but there's also a prime factorization way. We're going to focus on the perfect square way though. So let's look at our first example. It says simplify the following, square root of 24. So what we'll want to look for, I'm going to put that over here, look for a perfect square that divides the number. Evenly. All right, so 24. Let's think of all the numbers that divide 24 evenly. And let's see if any of these. So we'll go down the list. We're not going to start with 1. We'll start with 4. Does 4 divide it evenly? Yeah? Does 9?
No.
16? No. So 16 is actually too big, right? So the only ones that could work would be 1, 4, and 9. 1 doesn't get us anywhere. So we don't worry about that. 4 is the only one on the list that divides it evenly. If there's more than 1, you pick the largest one. So we are going to rewrite this as a product. So this will be written as square root of 4, that's our perfect square, times, what is 4 multiplied by to get 24? 6, so times square root of 6. So I broke it down into 2 factors. And then I'm going to simplify the one that is the perfect square. I can simplify this. What is the square root of 4?
2.
So this equals 2 times the square root of 6. Before I can say I'm done, I got to look at 6 and make sure none of the perfect squares evenly divide it. So I look over here. Does 4 divide it? 9? No. So my solution here is 2 square root of 6. So the way we would check that would be to put them both in the calculator and see if they are estimated to be the same as a decimal. So do square root of 24. And then 2 times square root of 6. They're the exact same. This 2 square roots of 6 is called an exact answer or exact solution. We use this in algebra with the quadratic formula, and then you'll use it again in geometry and algebra 2. So that's why you need to know how to simplify them. Let's look at the next one, 512. Ooh, that's a big number. Let's see. We'll go down the list, and we want, remember, the biggest one. So we can start dividing them if we want. Does 512 get divided by 4? Yes, but not sure if that's the biggest. 512 divided by 9. Nope. 512 divided by 16. Yes, okay. So right now 16 is the biggest. 512 divided by 25. I know that's not going to work. 512 divided by 36. Nope. 512 divided by 49. Nope. 512 divided by 64. Yes, so 64 is now the highest. Let's keep on going. Because we need to get up to at least half of 512. Divided by 81. Nope. We know 100 is not going to work. 512 divided by 121. Nope. 512 divided by 144. Nope. 512 divided by 169. Nope. 512 divided by 196. Nope. 512 divided by 225. Nope. 512 divided by 256. Yep. And that's the largest one I can even get because it's divisible by 2. So 256 divides it evenly, and 256 is a perfect square. So we're going to rewrite this as the square root of the largest perfect square that went into it, 256, times the number that would be multiplied by 256 to get 512, square root of 2. Then we actually take the square root of the number. So square root of 256, which is the 16. So 16 times square root of 2. Or 16 square root of 2. We can double check it in our calculator. Square root of 512. 22.6. Let's do 16 times square root of 2. Same thing, so we did it correctly. So the next one, 49. We need to find one of the perfect squares that will evenly divide. Did I say 49?
Yes.
98. Sorry. Got ahead of myself, I think. All right, so you check and see what will divide it evenly. So 98 divided by 4. No. 98 divided by 7 is 14. But 7's not a perfect square. 49. 98 divided by 49. Yep, it's 2. So we rewrite this as square root of 49 times the square root of 2. What's the square root of 49? So 7 times square root of 2. So 7 square root of 2. So let's check and make sure that's right. Square root of 98. 7 times square root of 2. Yep. Okay, let's do another one down here. -2 square root of 48. I'm changing it up a little bit. We need to simplify that. We're going to leave the -2 just out front. We're going to focus on the 48. So we need to look at our list and see what perfect square evenly divides 48. 16. 48 divided by 16. It's 3, yeah. So I'm going to rewrite it. -2 times square root of 16 times square root of 3. So then I can actually take the square root of 16. So now I have -2 times square root of 16 is 4 times the square root of 3. Then I simplify even more just by multiplying those two numbers. -2 times 8 times 4. -8 square roots of 3. So let's double check that that's right. There we go. And they are the exact same. What about square root of 13? Is there anything that can divide it evenly? This would be called prime. It can't be divided, so it's just prime. All right, I'm going to pass out the assignment that you're going to work on right now. You'll glue this in your journal if you need to fold it or something to get it in there. There is one mistake on here, and it's here. This should be a positive. For some reason, a negative got thrown in there.